Hello and welcome to the next video in my Pre-Algebra review series. Today's video covers Chapter 6, Section 4 of your textbook, entitled Probability. By the end of this video, you should have a better understanding of finding probabilities and finding odds. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them and certainly help this channel get seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Okay, objective 1 on this slide, finding probability. It's a pretty full slide, I guess I could say. There's a lot of info on here. We're just going to read it and try to understand what's being said and asked for in the questions at the bottom. But it starts off by saying here that many board games involve rolling two numbered cubes and then adding the numbers on the cubes. I'm sure you've played these games before. Are certain sums more likely to come up than others? So are you more likely to get a 4 than to get a 2? That's the kind of, how often can you get a 4? Or are you going to get 4s more often than 2s or vice versa? We're going to find out right now. The table on the right, that's this colored table here, shows the possible rolls and their sums. Well, the numbered cubes have 6 numbers on each cube. There's 6 sides to the cube, so they all have a different number on them. So you can have one cube can have a 1, the other cube can have a 1, and then when you add them together, you get a 2. That's what we're looking at right here. When we look here, we're adding 1 and 1, and we're getting right here the 2. Okay, you see that? So any one of these we pick, it can happen. We can say, show me where I can get a 9. Well, I can get a 9 by doing a 5 here, and a 4 on this cube will give me a 9. I can get a 9 by doing a 5 on this cube and a 4 on this cube, the different cube. I can get a 9 by getting a 6 on the first cube and a 3 on the second cube. Or down here I could get a 9 by doing a 3 on the first cube and a 6 on the second cube. So there's 1, 2, 3, 9. The 9s, there's 4 9s in this table. Okay, so that's kind of, and you can see let's move on to the next one. It says the outcomes of possible results of an action. That's what an outcome is, the possible results of an action. There are 6 outcomes for rolling a single numbered cube, 1 through 6. An event is any outcome or group of outcomes. The outcomes are called favorable outcomes. So we're looking for you want to get a 6, you need to get a roll 6. So that's your outcomes. That's your favorable outcomes. Are called favorable outcomes. In rolling 2 numbered cubes, for example, rolling the sum 4 is an event corresponding to 3 favorable outcomes. Shown right here. You could have a 3 and a 1. Let's see where we at. We can have a 3 and a 1. A 3 on one a cube, and a 1 on the other cube. You can have 2s on each cube, or you can have a 1 and a 3. One cube can have a 1, and the other one now can have a 3. So those are the possible ways of getting a 4. Okay? 3 outcomes result in the event the sum is 4. So the outcomes for rolling 2 numbered cubes are random. So unless there's something wrong with the cubes, they're loaded or something to make them change the way they're going to fall, they're considered random. And because of that, statistically, we can assume that they're natural, and whatever is going to come up is true statistics, not something favored because of cheating or something like that. So it's random and equally likely to occur. When outcomes are equally likely, you can use the ratio to find the probability of an event. And we've been talking about this a little bit. So what is the P of an event? The probability right here. Probability of an event. The probability of an event is the number, right here, the number of favorables divided by the number of possible events. So in our table, The possible events are 36. You can have 36 different, 6 times 6. 30, you can have 36 different possibilities. But what we're looking for, if we're looking for 4s, for instance, there are 3 ways, 1, 2, 3 ways of getting a 4. And so what is that ratio then? It's 3 divided by 36. Because you got a 3 on the top, the number of favorable outcomes, and 36 is the number of possible outcomes or events. So that ratio there in that case would be 3 over 36 would be equal to 1, what? 12th? Okay, 1/12. So 1 in 12 times. If you throw the cubes 12 times, the chances are straight even that you'll get at least a 1 of those 12 times. You'll get the 3 one of those 12 times. So, keeping that in mind, it says copy the table and complete the missing values. So what are the missing values? We've talked about them. What are they? We know how to do them. So there are two cubes. One is going to be called cube number 1, and the other one's cube number 2 with the 2, subscript 1 and subscript 2. So they're looking for this question mark in this row right here. It says, what is the number here that we're looking for? We're looking for the cube number 1 to have a 4 on it, and cube number 2 to have a 1 on it. And a 1 and a 4 make what? 1 and 4 makes 5. In this row here, we're looking for cube number 1 to have a 5 on it, and this cube number 2 to have a 2 on it. 5 and 2 is 7. 7 right there, 7. Okay? This row, we're looking for this question mark here. We're looking to have cube number 1 to have a 3 on it, and cube number 2 to have a 3 on it. And if we do, we're going to have 3 plus 3 is 6. Okay, in this row, we're looking for cube 1 to have a 2, and cube 2 to have a 4, and 2 and 4 make 6, so here's another 6. Over here, this question mark here, it says we want cube 1 to have a 6, and cube 2 to have a 5, which would give us an 11. There's our 11. And then in this row, the last row, we want cube 1 to have a 1, and we want cube 2 to have a 6, and that'll give us a 7. Okay? And if you look along here, what is the number that has that's the most frequently? So it says the next one, what is the number of times each sum appears in the table? Well, that's interesting. Let's do this first. The answers are right here in this long list right here. The number 2, right here, number 2, appears 1 time. The number 3 appears 2 times. The number 4 appears 3 times. The number 5 appears 4 times. The number 6, 5 times. The number 7, 6 times. The number 8, 5 times. Oh, now it's going backwards. 6, it's going to go 5, 4, 3. The number 9, 4 times. The number 10, 3 times. The number 11, 2 times. And the number 12, 1 time. So it goes 1, 2, 3, 4, 5, 6 times, then 5, 4, 3, 2, 1. Okay, so now we found out which, it says the sum that appears in the table. It says which sum appears most frequently. Most frequently is the 7s. We can look right here in our table. There are 6 7s in the table, right here. And on either side of that, there's less of all the rest of them. 5 8s and 5 6s. There's 6 7s. Okay? So that's 7 is the one that appears most frequently. Okay? And it says, question 4. There are 36 sums. We discussed that in this table. Use your answer to question 3, which sum appears most frequently, which is the 7, to write the ratio of the number of times the most frequent sums appear. Well, the most frequent sum is 7 divided by, 6 divided by 36. And that equals 1 over what? 6. 1 over 6. 1 and 6 times. So if you roll the cubes 6 times, you should come up with a 7 at least one of those times. So that's the probability. The probability that a 7 will come up is 1 in 6. Okay? Okay, finding probability, which is the same concept on this slide. Find P, the probability of rolling an even number. Now they want to know the probability of rolling an even number with one 6-sided number cube. So how many numbers can you have on a single 6-sided number cube? You can have, what we've determined here is we can have 6 possible numbers, 1 through 6. And of these 6, we have a 1, a 2, a 3, a 4, a 5, and a 6. How many of them are even? Oh, well, there are 3 even numbers between 1 and 6. And here's the total number 6. So the number of favorable outcomes divided by the possible outcomes is 3 out of 6. So that means, since it's even numbered, you got the 3. Well, 3/6 is equal to 1/2. So if you roll these 2 or this 1 cube, every time you roll it, the chances of getting an even number are 50-50, 1 and 2. Half the time you're going to get an odd number, and half the time you're going to get even. And if you do it enough times, the statistics never work instantly. It's over a time. If you roll it 100 times, the more you run it, the closer it's going to become perfect to this 1/2 of the time. Okay? So let's check our understanding they're asking here. So what on example 1? Find the probability of one roll on a numbered cube. You're going to roll a cube, same as we just did in the previous slide. So now they're asking what's the probability of getting an odd number? Well, if it was 3 and 6 for an even number, there's only 6 numbers, so for an odd, it's going to have to be 3 over 6 also, and it's going to be 1/2 the time. So half the time you're going to get an even number, and half the time you're going to get an odd number. Okay? What's the probability that you're going to roll a 2? Well, how many 2s are there on the dice? There's 1, 2. And how many possibles are there? We already know that. There's 6 possible outcomes. So 1/6 of the time you can get a 2, 1/6 of the time. How about probability of a 5 or a 6? Well, there's each of these is 1 on the cubes, so that the 2 together means 2. You have 2 favorable outcomes over your 6 possible outcomes, and that equals to 1/3. So 1/3 of the time, you're going to roll a 5 or a 6. We don't know which one, but you're going to roll a 5 or a 6 1/3 of the time. And how about this one? The probability of getting a 1, 2, 5, or 6. Well, those are 4 of the possible events out of 6. So 4 out of 6 times, you're going to be able to get a 1, a 2, a 5, or a 6. Well, if you take this and you reduce this, it's going to be 2/3, right? 2/3 of the time, you're going to be able to get a 1, a 2, a 5, or a 6. Because the other third of the time, you're going to roll the 3 and the 4. So that's what this is telling you. Okay, real world problem. All probabilities range from 0 to 1. So the probability is 50%. You saw we had these fractions, 1 over 6, 2 over 6, 5 over 6. They're all fractions. They can go from a 0. If you have a lot of possibilities, you can get very close to 0 if you don't get any. If you want 99 out of 100, and the probability of getting 99 out of 100 is almost 100%, or 1. It's 99 over 100. But that means 1 is not going to be as likely, right? 1 out of 100 chances. So that's what they're kind of showing you here with this number line. So less likely is the smaller numbers, more likely is above 50%. So that's where using 50% is the median here. If it's greater than 50%, we're more likely to get what we want. If it's less than, we're not. So an impossible event, a likely event, or likely as unlikely, it's either or a certain event. Okay? So if you get way down here at 0, it's almost impossible to get whatever would cause that, because you're going to get all these other possibilities. So the complement of an event is the opposite of that event. So if you get 5 out of 6 is what your event is, the complement of that would be 1 out of 6. Be like the opposite, whatever is the remaining part. Okay? The events no rain and rain are complements of each other. It's either going to rain or it's not going to rain. One is one and the complement is the other. The possibility of an event plus the probability of its complement always equals 1. So if you take the possible, that we said we had, let's do quarters. 3 quarters, you have 4 possible outcomes, and your favorables are 3 quarters, or 3. So that's 3 quarters, or 0.75. Well, what's not considered here is the complement of that, which is 1 quarter. And that's 0.25, or 25%. And 25% plus 75% is 100%. That's what they're talking about there. In the United States, the probability that a child is born a twin is 2 out of 90 births. That's 2 out of 90. Find the probability of not a twin. Well, if it's 2 in 90 is being a twin, then the opposite of that is going to be 88 out of 90 is going to be the complement of that, because 88 and 2 is 90, and 90 over 90 is 1, right? So that's 100%. So over here we got a probability of a twin plus the probability of not a twin equals 1. Okay, so 2 90ths plus the probability of not a twin is 1, or minus, that's interesting, the math here, minus 290 plus 290 plus the probability of not a twin is equal to 1 minus 290. Subtract 290 from each side. The probability of not a twin is 88 out of 90, or 44 out of 45. That's the probability of not having twins. So that's the probability of a child that is not born a twin. Check your understanding. When you roll a numbered cube, what is the probability, P, of not having a 2? Well, what did we determine? We know that a 2 occurs 1 out of 6 times, because there's only 1 2 of those 6 numbers. So what's the probability of the complement? Well, the complement, so this plus the complement, what's the number here? X. It's going to be equal to 6 over 6. The only thing we can do here is 1 plus 5 is 6 over 6, which is equal to 1. So X in this case is equal to 5. 5 possibilities. The 5 other chances of getting another number. What is the complement of an impossible event? The complement, if an event is impossible, its possibility is, let's say it's very near to 0. So the complement of an impossible event is 100%. 0%, 100%. That's the complement of 0%. The closer you get to 0%, the more the complement goes to 100%. Okay? Finding odds. So now we're going to talk about the odds, not the probability of an event, but when they talk about what's the odds, what are the odds? Well, you can think of a probability as a ratio of a part to the whole. 1 out of 6, 2 out of 10, 6 out of 36. a part, a number, a part of the whole over the whole. You can also use a part over a part. That ratio is called odds to describe the likelihood of an event. So it's the part of a part over a part. So what is the odds in favor of an event? Odds in favor of an event, right? Where'd my pen go? Odds in favor of an event are the number of favorable events divided by the number of unfavorable events. So if when we go back to the dice, the odds of a favorable, if you want, how many times can you get a 1? We say that that's 1/6. Well, the favorable is a 1, and the unfavorable would be 5. Now we're talking about odds. So the odds are 1, and the way we word that is we'll say 1 in 5. 1 in 5. Here's another one. What are the odds against an event? Odds against. So that's just the opposite. That's the unfavorable divided by the favorable. So in our case here, the unfavorable event would be, the opposite of this would be 5 over 1. Just the opposite of that. Or 5, the odds are 5 to 1. You hear that at racetracks and stuff. You hear, oh, the odds are 5 to 1 to win or whatever. So that's what they're talking about, odds against and odds in favor. So in favor is you put the favorable events over the unfavorable events. Odds against something is you put the unfavorable events over the favorable events. A real world problem. This is a little tricky, but let's see if we can make it work here. There are 5 wood blocks in a bag. 5 blocks. 3 of the blocks are red and 2 of the blocks are green. Additionally, 1 block has a letter painted on it and 2 blocks have numbers painted on them. If you select 1 block from the bag at random, you just stick your hand in and pull it out, as we sit here without looking, what are the odds that you'll select a red block? What are the odds that you'll select a red block? Because you're pulling out, you want a red block, so the favorable event is getting a red block. So now we're going to say, well, there's 3, as you can see here, it says that there are 3 over 2. There are 3 red, up here at the top, 3 red and 2 green. So the odds are 3 to 2, reds over greens, 3 to 2, that you're going to get a red block. What are the odds in favor of 3 to 2? Well, it says here's the odds in favor, where here they wrote out the equation. So now we're just saying it the way I just did up here. 3 to 2 or 3 to 2 in favor of the red block. The odds in favor of having a number painted on it is what? We're not worried about color here. We just want to know what's the odds of having a number on one of the blocks. Well, in this case, we said that there additionally here, up at the top, it says there's 1 block that has a letter, and there are 2 blocks that have numbers. So the 2 have numbers. How many blocks are there? There's 5 altogether. So in that case down here, the favorable event is 2 right here. That's 2 with the numbers, and 3 don't have numbers on them. So in this case, the odds are 2 to 3 in favor of a numbered block.